Morning, it's time to begin. Rainy, kind of a cool day. We're going to continue with polynomial functions. And we studied last week the ending behaviors. If it's an even powered first term or degree, then it either ends upwards or downwards, depending on whether positive or negative. And then it also, if it's an odd powered degree equation, then it will go upwards, left to right. If it's positive, or downwards, left to right, if it's negative. That being said, we'll go ahead and get started on this. Today, we're going to begin with identifying zeros and multiplicities of zeros. So, values of x in the domain, which x are 0, are called the zeros of the function. I have an example here. Okay, this is an equation that we have factored, and we factored it into x squared times quantity x minus 3 times quantity x plus 2 squared times x minus 1 cubed. That means this is actually x plus 2 times x plus 2, and this is x minus 1 times x minus 1 times x minus 1. And this means x times x. Okay, what we're saying is if x equals 0, should have put the word if there, then we have the values of, oh, I know what I did. This produces an x value of 0. This produces an x value of positive 3, of negative 2, and of positive 1. Okay, that's what I've got on these. Now, we're going to be dealing with the impact of these powers is part of what we're going to be dealing with today. Now, these we call roots. We call these the roots of the equation. Okay, and if x of x equals 0, then that corresponds. Basically, these are the values of x on the x-axis. Okay. Now, given this equation, x cubed minus 5x squared minus 6x plus 80. In this case, this one is going to be a cube, and the first term is positive. That means if we graph this, it's going to go upwards like that, left to right. Okay, we factor this by grouping. Okay, we take the x cubed and minus 5x squared and factor x squared out of both of those. We take this and factor a negative 16 out of both of those, making this become negative because we factored out the negative, and we're setting it into equal to 0. Okay, so if y equals 0, if f of x equals 0, then that means the values produced will be on the x-axis. Okay, we factor out the x minus 5 here and here. That's the grouping process. And it gives us these two terms. This one will further factor. And this gives us the value x equals positive 5. This factors further into plus or minus 4. Or we could use the conjugate rule and x minus 4, x plus 4 for that, which would give us this same pair of values. So we have three places where this graph crosses the x-axis. Okay, in this particular instance, then what that means, I have x equals 5 right here. 0.050, and then x equals positive 4, the 0.40, and the point negative 4. Negative 4, 0. Now, that combined with what we know about the ending points, we know that this graph has to come upwards, left to right, like that. So these ending points are going to go like that. Now, what we're going to be doing in the next few minutes is discussing what happens in the middle. Obviously, this is going down, and that's coming up, but something's got to happen somewhere. Maybe this could turn here and turn here like this, but there are actually some rules that tell us how it's going to behave so we can predict its behavior accurately. And that's where we're going for now. Okay, I'm not going to finish this problem right. Well, actually, I will. In this case, all of these are single exclusive values. So these are what we call crossing points. So it has to cross to the other side. What that means for us then is that this graph will come up here somewhere at positive 80. All the way up here. This thing's going to be coming pretty steeply. Then it's going to be coming back down through this point and then back up through this point. Probably a little steeper than I had originally drawn it. Okay. We'll also find out how to go, what this one is. This one we got because of the y-axis, and it was evenly spaced between these two. So we'll go on and get some more detail as we continue. Okay, in this problem, we're not going to work it to fulfillment, okay? But basically, we're going to look at this. This is a cubic again, so it's going to, and it's positive, so it's going to go low to high. We know that the y-intercept is going to be 25. We could graph this one, or we could find the zeros by using the factoring by grouping again on this one. So let's go ahead and do those requirements. I'm going to factor out 4x squared out of the first two terms, leaving me x minus 4. Excuse me, x minus 1. And then I'm going to factor out a negative 25 out of the next two. So I'm factoring out a negative 25, and that would leave me x minus 1. Pull out these two terms, factor them out. X minus 1. And what have I got left? 4x squared minus 25. Okay, once again, perfect square on the front, perfect square on the back, minus in the middle, that's a conjugate. So it becomes 2x minus 5 and 2x plus 5 equals 0 in all of these cases. So I got an x value of positive 1. If I take the 2x minus 5 equals 0, add 5 to both sides, 2x equals 5, divide by 2, x equals 5 halves. These two will give me values of positive 5 halves and negative 5 halves. These are the zeros of that function that it's required. By the way, what is the y-intercept? Okay, these are the zeros. The y-intercept is 25. Actually, the point 0, 25, I should be particular. Okay, and based on that, we're going to be able to graph this in the future. But right now, it just wants us to find this fundamental information. Okay, here's another one. This one's actually easier to factor. We can factor an x out of all three terms, giving us x squared plus 10x plus 25. This further factors into x plus 5, x plus 5, or x times x plus 5 squared. So our roots then are x equals 0 and x equals negative 5. Okay. Now, that's all this problem has asked us to do. In the future, like I said, we'll carry on. By the way, what is the y-intercept on this thing? Considering the original equation, the y-intercept is 0. That means that the y-intercept is at the origin, 0, 0. Now, if a polynomial function, okay, polynomial just means that it has more than one term in it, okay? For example, x squared plus 2x plus 5 is a trinomial, polynomial meaning many. Okay, so if we have a polynomial function that can factor into x plus or minus some number, like x plus 3, exactly k times, then c is a zero multiplicity. If you remember in that last problem, I had x times x plus 5 times x plus 5 in the last problem, which I rewrote as x plus 5 squared. This is what I'm talking about. Now, let me put this back up here again. If this is a zero of odd multiplicity, it's going to cross the x-axis. Okay, there's a hidden first power right here on this. That means because this x is a first power, that when we come to the x-axis, wherever that is, and that one's going to be 0, that this is going to cross. Okay, that way or this way, but it'll cross. Now, in this case, we've got the point -5, because x plus 5 equals 0, x equals -5. This one is going to be called an even multiplicity. Now, this is different from the even and odd that we studied earlier. Don't try to confuse those terms. This is multiplicity, odd or even. Now, this one is even. What that means is this graph is going to come down, touch, and turn either that direction or this direction, depending on some other factors in the problem that we don't know right now. Okay? But an even multiplicity, 2, 4, 6, 8, 10, power of something, means it's going to be a touch and turn or touch and go, like an aircraft coming down to the runway, just touching the wheels and take off again. We used to watch Air Force One when it was manufactured here in Wichita, do that out at ICT. They would do that a number of times during the testing process. Okay, even if it touches and turns or touch and go. Let's look at this factored equation. This is a factored equation. We got 8x that we factored out of everything. We got a pair of these and 3 of those that would all have to be multiplied out if we wanted to find the original equation. Okay? Now, what is this saying? Well, this is actually a totally different problem right here. Okay? But let's deal with this one. This x produces a value of 0. It has a multiplicity of odd. That means in the graph, okay, the value of 0, and it's going to be a crossing point. Now, this one has a multiplicity. Oh, that's still on that one. Okay, this one, you get x equals 1. So we graph that point. And it's going to be a multiplicity even. So it's going to be a touch and go. The third one, you're going to get x equals -3, and it's multiplicity 3, or in other words, multiplicity odd again. So here's -3, and it's going to be a crossing again. Now, what else do we need to know about this thing before we can graph it? What's our total powers? 1, 2, 3, 4, 5, 6. So overall, this is an even degree. What do we know about even degrees? They make U's or W's. what do we know about a positive? If we look at all of these x values, they're all positive. So that means that this thing's going to open up and end up. So what does that mean for us? That means this point's going to be heading up that direction. This point, which is a touch and go, is going to be going up that direction. Now, what's going to happen in the middle here? This is going to cross, so it's going to go down some amount and turn and come back here, go up some amount, turn, come back here and do a touch and turn, and then go back up. So that's going to be the general shape of this graph. Okay? So we're beginning to learn how to sketch graphs based on pieces of information. The leading term degree tells us whether it's this or whether it's that. Okay? The degree of the factored components tell us whether they cross or whether they touch and go. So these are all factors that we can use. All right, so let's go on to these two. First, let's read the directions and see what they want us to do. Determine the zeros and their multiplicities for the functions. Okay, this is already factored. That one is a constant, so it does not produce a zero. However, this negative is significant because that means it's either going to go down and down or down and out. So what are our zeros here? Well, we're going to have x equals -3. And that's an even multiplicity. So this one's going to be a touch and go. What about this one? Well, 5x, funny looking 5, minus 1 equals 0, plus 1 plus 1, 5x equals 1, x equals 1/5. That really means that there would be 5 of these except they're all in one point. So we get x equals 1/5. Now, that one, because of the odd multiplicity, is going to be a crossing point. Okay? So if we graph that thing, we've got the point -3. We've got the point 1/5. We know that this one is crossing, and we know that one's touch and go. Our leading sign is going to be negative. So that means we've got to do this and end with that. Okay? So what are we going to end up with? Oh, this one is a touch and go, so that means this is going to come up here, turn around, and come up there. Now, we can find this y-intercept by taking -1 to the 5th is -1, 3 to the 4th is 81. Let's see, 3, 9, 27, 81, yeah. 81, and it's positive, so now I've got a -81 and another negative and 3/5 times that, and I could find that. But we'll not do that on this problem. We also could let we could find out what this is by substituting these x values into the equation. And at halfway between, right here, let x be like -1 and see what we get to get an idea of how deep to go there. Okay, that was a little awkward. Now let's go to this one. 2x to the 6th minus x to the 14th. We factor that, 2 will come out of everything, and an x to the 4th will come out of everything. And that leaves us x squared minus 7. Okay? Well, this is going to produce x equals 0. But that, we've got to go over here, x squared equals positive 7. Take the square root of both sides, plus or minus, and we get x equals plus or minus square root of 7, which is about 2.5 something, I don't remember. Okay, is approximately 2.5. Okay, plus or minus. So that gives us our zeros on that one. For the most part, you can just leave this as plus or minus square root of 7 for your answer. Unless you physically have to graph it. What effect did the multiplicity of 0 have on the graph? And let's look at what the leading term. What is our leading term? X to the first, x to the second, x to the third. It's a cubic. A third degree, that means it's going to start low and end high because all three of these x's are positive. Okay? Now, let me back up. All three of these are also odd multiplicities. That means that all three of these points are crossing points. So if we come up here and go up there, we got to come down, loop around, cross, cross, or from this direction. Do we know how high to go here, how low to go there? Well, we're going to be doing that in a few minutes. Now, look at this over here. These are the steps for finding the graphs. Plot the roots. Boom, boom, boom. Determine the endpoint of that behavior. Up and up. And then you can sketch it. We can find the y-intercept. Okay, what about the y-intercept on this one? Okay, you see x cubed is our leading term. And here's our end behaviors that we talk about. Well, we can find the y-intercept on this. 3 times -1 times a hidden 1. So the y-intercept then okay, where do I get that? Here, here, and there. Okay. Okay, the y-intercept. In this one, it said it should be 3, so they don't have this thing drawn exactly correctly. The y-intercept on this one, oh, is 0. I got careless. Okay, different equation. This time I've got a second power on this first term. Okay. Now, what are my zeros? That means that this one is going to be a touch and go. I've got 1, 2, 3, 4 degrees. So the end behaviors on this one, because that's a 2 instead of a 1, is going to be generally W-shaped or U-shaped. Okay? So x minus 1 gives you a x equals 1. X plus 3 gives you the negative 3. This one is crossing. Okay? 0 is crossing. Now, if that had been an x squared, then that would have been a touch and go. This also would have been a fifth degree equation. So here's our ending behaviors. Here's our total degree of the equation. This time we're changing it around again. Okay, this will produce a 0 here. This will produce a 1 here. And it's going to be crossing. This is going to produce a negative 3. And it's going to be touch and go. The total degree, 1, 2, 3, 4. Okay, we've got a factored equation this time. This is going to give me a 0. That's going to give me a negative 4. That's going to give me a positive 7 with a crossing, crossing, touch and go at the 0. Okay, so 0 has a multiplicity of 2, so it's going to be touch and go. Negative 4 is going to be crossing. The 7 is going to be crossing. Okay. Now, turning points are points where it changes from increasing to decreasing or decreasing to increasing. What does that mean? If this is a turning point, it either goes from decreasing to increasing, or depending on the equation, goes from increasing to decreasing. But it changes direction at that point on the x-axis. Okay. Now, we're going to be talking about the relative maxima and minima. Turning points, on the other hand, crossing points, turning points, there can only be one less than the total degree of the equation. If it's a fourth degree equation, first term x to the fourth, then there can only be a maximum of 3 turning points. If it's a fifth degree equation, there can be a maximum of 4 turning points, but there don't have to be any. Okay, I've got the equation x cubed minus 21x plus 20. Okay, we look at the end behaviors. That's positive, so it goes from down to up. Let's find the ending points. Well, to do that, we know that there can be at most 2 terms. Now, here's our 2 terms. Using that n minus 1 rule. Okay, determine end behaviors, find the y-intercept, find the zeros and their multiplicities. Okay. Plot the X and Y intercepts and sketch it. Number 5, draw a sketch from the left end behavior. Connect the intercepts, the points on the x-axis. Okay, cross or turn depending. Now, 6 and 7, this is an optional one. You don't really need to do this. This is kind of a bunch of extra work, although if it's a parabola or something that's symmetric, it can save you some time instead of having to do an XY plot. Okay, so we look at this. What is the general shape of this? Second power, third power, fourth power. General shape is this. Okay, so for x to the fourth, this is your general shape. How many turns can we have? A maximum of 3 turns. Now, are these turns gonna, what are the intercepts? Okay, so if we let x equal 0, then y is equal to -12. So the y-intercept is the point 0, -12. Now we're going to find the x-intercepts or the zeros or the roots. Okay? This one gives us a root of 1 of multiplicity 2. So that's a touch and go. This one gives us a root of -3. It's a single multiplicity, so it's crossing. And this 4 is also crossing. So based on these points, we've got the point 1, which is a touch and go. We've got the point -3, which we know is a crossing. And we've got the point +4, which we also know is a crossing. We've got the y-intercept, which is -12 down here. Okay, we know that we can have at most, because this thing is 4th degree, we can have at most 3 turns. We already figured out that the ending behaviors have to be this way. So this point has to be upwards. This point has to be upwards. So this thing comes down here. Okay. And then comes back up here. Now you might think, well, that's just, actually it's going to be more like it's going to come over here a ways and then come up and down farther, because this is less than halfway between those two. So that's kind of the general shape we're going to get on this. Now you might ask, well, why isn't this one a W? Because this 1, oh, I left out a point. This graph, this drawing, this part of this drawing is all wrong. I got careless. This is the point that has to go out that way. The far end point, which in this case is defined by this. Now, that being the case, we know this has to come down. We know that this one is a touch and go. So this thing's going to come down here some distance, come up, touch, come back down through here, and then up is what this one's going to be. Now, 4th degree, maximum of 1, 2, 3 turns. Okay? So that's what that graph would look like. Okay, we're going to graph this equation. In this case, the 1 is our point here. What are we doing here? They're testing for symmetry, and it's not, but that's an optional step. Now, what they're telling you is if these are the points that you get on this problem, okay, that basically you want to pick points between them. Okay. So since we've got the point -3 and +1, we're going to pick a point between those, ideally about halfway. They chose -2. I probably would have tried -1. But anyway, they did that, and they got down here at -63. Let's see, 10, 20, 30, 40, 50, 63. Okay. So anyway, they found a point about there. So they know that this thing's got to come down and up like this. Now they want to pick a point between here and here and see what happens. Okay. Well, you get a -24 down about here. So let's see what we get on these. This is our graph. Now, how did we get up and up? Negative times negative is positive. Negative times negative is positive. So overall, the leading sign is positive. Okay. We know that this one has to be a touch and go. We know that this one has to be crossing. We know that that one has to be crossing. Okay, what do we know about these? I've got an even multiplicity, an odd multiplicity, and a negative leading term. So the shape is going to be a cubic, second power, third power, with a negative out front. So that means that this is going to go high to low before you're finished. We can have at most 2 turns in this thing. Now let's find the values. Our x values are going to be -1 and +3. Okay. Our y value, our y-intercept is going to be -9. Now, this is going to be continued on the next page. So remember that the y-intercept is -9. We know that overall it's going to go up left to down right. So let's continue with this one. From here we find x is -1, and here x is +3. So those are our x-intercepts. This one is a crossing, and this one is a touch and go. So here is our -1. Here's our +3. Our y-intercept is -9. This one's a touch and go. This one's crossing. Now, how low does this go on this curve? Well, we can try a point somewhere between here and here. 1, 2, 3, 4. In my case, I would try here to get it, but in reality, the lowest point came about not quite. This isn't perfectly symmetrical between those two. But if you tried x equals 1, you still would have gotten approximately 1 3/4. Well, that's 15, so that's not true to scale. Okay, let's look at these examples. There's our equation. It factors into x times x squared minus 4. X squared minus 4 is a conjugate, which factors into x plus 2x minus 2. It's a third degree equation, negative, so this is going to go up to down. Now, what are our values? This x produces a 0, this produces a -2, this produces a +2. We graph those 3 points. All 3 of these are crossing. Okay? Now, here's our general shape. This comes down here so far and comes up here so far. We don't know how far. So I'm going to try something between 0 and -2. I'm going to try -1. So I put -1 as the next value and I get -3. Okay, right here. If x is -1, then y is -3. What about on this side? Well, if this is 1 and that's 2, I'm going to try +1. So if I put +1 in here into the equation, I get x equals 5 here. Now, to be more accurate, I could try 1/2 and I could try 2.5 or 1.5 and see where this thing actually turns. But for an approximation, we could just do that as our graph to get an approximation. I better watch the time. I'm almost out. Okay. Now, let's look at problem number 1 up there. I'm telling you that x is 2, -2, and 3. Now, what that means for you is you've got these 3 terms. Okay? Now, if we wanted to find the original polynomial, that's statement number 1, we would multiply these 2 together, getting x squared minus 4, and take that times x minus 3, giving us this equation, which simplifies to that. Okay? It would give us this trinomial, this cubic. Now, this thing is positive here, so that means it's going to go from down to up. We plot our 3 points that we've got. Okay, all 3 of them are crossing. The y-intercept of this thing is 12 up here, where x equals 0. So that means that this one's got to come up at least this high and over here. Now, how far down over here? Well, if this is 2 and that's 3, then we would try 2.5 in an XY table to find out exactly how far down it went. Okay, now we're going to do question number 2. In this case, it's already factored for us. For B, you could do some multiplication on this thing. X minus 3 times x minus 1 is this. And then you could multiply the 2x times all of that, which would give you this equation. Okay? 2x times this is 2x squared, 2x times that, here, 2x times that is here, and then you would have a 0 y-intercept right there. We find the other points, 3 and 2. Okay. Here are our 3 points. This is a cubic and it's positive, so it goes from low to high. And then we would just have to try a point to do an XY table halfway between here and halfway between here to get our approximate depth on our maximums and our minimums. Now, tomorrow we'll continue this topic and we'll start with if x is plus or minus square root of 3 and positive 2. So that's where we'll start tomorrow on this example 3. I hope this is beginning to fit how you can sketch these curves. We're going to practice it some more and then continue. Goodbye.